don't know me, my name is Ms. D. I'm a certified welding educator, certified welding inspector, and a certified radiology interpreter, okay? I want to show you all the different things we can do, all the, you know? Okay, all right, so today, first thing we're gonna work on is shop etiquette. Yeah, that's a big deal, and I think sometimes people don't realize it's a super big deal when you go into a shop. Can you guys name some things that maybe a do and a don't? Ideas, thoughts? Great idea. Don't wear shorts. All right, so shop etiquette. Wear appropriate clothing, right? Jeans, long sleeves. Make sure you clean up. If you have nothing to do, you finish your projects, what do? Organize, sweep the shop, clean up, make sure everything's on the up and up, right? That also means putting your tools away, sweeping the floor, making sure you have no extra materials or scraps, that it goes where it belongs, okay? And I know this is a big hurt for a lot of people. Don't use somebody else's tools unless you ask. I can't tell you how many fights that has caused. Okay, hey, can I borrow this? Oh yeah, it's in my toolbox. It's right, da 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 da. Sure, cool. Don't go into somebody's toolbox. Don't take somebody's tools unless you ask, okay? It's a super big one, and a lot of people don't realize it. Oh, I'm just gonna use it real quick. I get miffed if I leave a tool there, walk away, turn around for something, come back, where's my tool? You know? So make sure that you guys are paying attention to the shop etiquette. Here's the other thing. Make sure everything is clean. Do you know why? I can't tell you how many times I've slipped on rods, I've slipped on slag, or anything else, okay? So it's like really kind of important that you guys keep your areas clean, whether it's here, whether it's in the shop, because you can hurt yourself, okay? And same thing with tools. Don't leave your tools down, right? Always pick them up. Make sure that you know where your tools are. Mark all of your tools. If somebody happens to have that same tool, who is it to prove that it's not theirs, right? Okay, so make sure we keep that going. All right, now I got 3 rules for you. Miss D's rules for welding, okay? These are kind of important, and these will actually help you throughout your career. Rule number 1, match your base metal with your filler metal. What am I talking about when I say that? So steel with steel, aluminum with aluminum, stainless with stainless, as best we can, okay? That's number 1. Number 2, we want to make our filler metal as strong or stronger than the base metal, which means matching the correct tensile strength with our base metal. Okay, super important. Rule number 3, 90% of what is done, whether it's a variable or changes speed, etc., it's based on thickness of material. If I have a piece of material this big versus this big, where's my amperage gonna be? Nowhere the same, right? This one's gonna be probably more, and this one's probably gonna be a lot less. So if you guys remember those 3 rules throughout your welding career, it really helps. You go, okay, because remember, if we don't have the correct base metal and our filler metal combinations, what's gonna happen?
Fail through it.
Well, I mean, it's not gonna work the way it's supposed to work, right? My weld could fail prematurely because I didn't match it correctly with what I was trying to do. Okay, so it's really important. Keep those in mind as you go along. And it kind of like, you're like, oh, I remember. She said something about this. And then all of a sudden it clicks and goes, oh, I get it now, right? Okay, so I want you guys to remember the 3 rules. Rule number 1 is match my base metal with my filler metal. to match, my filler metal as strong or stronger than my base metal. 3, 90% of what I do is dictated upon thickness of material. While we are running stick or SMAW, how long should your electrode be before you throw it away?
A little bit past the numbers, right?
Yeah, so right about the numbers, okay? That's about 3 inches long. A stick electrode can be used all the way till it's almost this big. Unless it is lacking flux on it, you should be using it that far. Okay, why do I say that? No, not just safety. And if you have that habit of tossing it because you couldn't strike it, what's your employer gonna say? Yeah, you're wasting money. Let me give you a good example, okay? That box is 7018. So where I used to go to school, we actually used to buy 50-pound boxes so we could practice, okay? That same 50-pound box, when I bought it, when I was going to school, was like $56. Okay, now it's almost $200. Because of the cost of steel. Okay, now, what is the industry standard for diameter of electrode for SMAW? 1/8 inch, good. So 90% of what we do is going to be an 1/8 inch. Okay, if we remember that, it will help you. Okay, now here's the other thing. How do I know if somebody hands me an 1/8 inch electrode, regardless of what it is, where do I start my amperage at? Well, let me show you a way you can do it. Okay, so we have an 1/8 inch electrode, right? Okay, does anybody know what this is in decimal form? Now you're close. 0.125. If you guys don't know how to do it, memorize them. 1/8 inch, 1/4 inch, whatever it is, memorize your decimals, okay? If you just don't know how to do it very well, okay? Memorize it. Really important. So now, if I have this into a decimal form, what I can do is I can knock off this point. This gives me a ballpark. It doesn't mean I don't have to go up or down with it, but if I look over a majority of 1/8 inch electrodes, this fits within almost all of them. Okay, so that means if I'm not really certain where to go, I'm going to put it into a decimal. And that's what I'm going to do. All right, what if I have like a 3/32? Times it, you divide. So I have 3 divided by 32. What is it, guys? Okay, so 0.0937. What would my amperage be? Where would I want to ballpark a 3/32 rod? I would probably say 90, right? 90 amps. Okay, it gives me an idea where to go. It doesn't mean, oh, I don't have to adjust it. It just means I have a starting point, right? Now then, when I start, what am I looking for? How do I know it's too hot or too cold? Okay, we could have a lot of splatter. What else? Well, when we look at our bead, if our bead is too cold, what is it gonna look like? So it's gonna be really kind of bubbly, like this. Kind of a mountain. We're really not gonna have a good, melting into the base metal. Your toes on your weld should kind of be really smooth, almost like a ski jump or a ramp, right? It's gonna ramp up from your base metal all the way up, okay? If it's too hot, I might see spatter. I might see it just gouging into the material. Or what would my bead look like if it was too hot? Right, it's gonna be really, really flat and very wide. Okay, so if it's really, really flat, so the weld will be flat and really wide. So really, when we have a bead, it should kind of be like a smooth up and a down, kind of like this, right? It's not totally standing up, and it's not completely flat. Kind of halfway in between. It'll have a little convexity to it, but it won't be like, bleh. Okay? That way you can start to judge, wow, is this too hot or too cold? Because you as the welder need to be able to determine that, right? Not just from rule 1, 2, or 3, although 3 plays a big part, right? Because now I might change my diameter if I have thinner material, right? Okay. Questions? What do you mean? Like the motion?
Yeah.
Depends on the rod. 70-18. All right. So 70-18 can have different motions. The one motion we do not, no, never. We don't want any loops. No loops. Why don't we want a loop?
No loops?
No loops.
Should trap it in the slag in, right?
Okay, you're gonna trap all the slag on the inside of your weld. So no loops. No loops. Okay, so when we go, I can do like an up and down, from side to side. Okay, something like that. If I'm doing vertical, I can do frowny face. I can do smiley face. Okay, so these are all of the movements that you can make without closing it. Okay, we just want to make sure that we're not going over it because we're going to trap the slag in. For the most part, flat and horizontal can have the same, but when we start to get here, we need to have a shelf to build. Okay, now, a lot of old timers, a lot of guys who've been welding for a while will say, oh, don't worry about it, the slag will burn out. Do not believe them! Why? Well, we believe them because they have experience, right? But I want you to kind of think about it for a moment. What temperature does slag burn out at?
Burn at it?
Probably a lot more than you're welding at, right? So, if I run over that slag, what's really going to be my consequence? Okay, I might be able to get a good weld, but interiorly, it's poor. Okay, if I'm doing any type of x-ray work,
So it'll crack, basically.
it could crack, yeah. It could just prematurely, break. But if I'm doing any type of x-ray work,
It'll come out.
done. Okay, so we don't get into that habit. Get into the habit of cleaning your welds well. Okay, it will help you more than you think. So then when an old timer says, oh, don't worry about it, I'm gonna worry about it because I want a good weld. Okay, so don't let somebody kind of coerce you into thinking it's okay. Okay, just because they have a little bit more experience and maybe sometimes they don't go to school for it and they don't understand what can happen. Okay. We are talking about this. So the first question is, why are 3 views used? Why would I use 3 views?
Are 3 views used?
Why? I put what there, but why? Why do we need 3 views?
That's what I was confused.
Views do we have here?
Side.
Top, front, and side, and this is a
Right side.
Pictorial.
pictorial. Okay, remember our pictorials are 3D view.
Pictorial.
Pictorial. What 2 views is the length of the object seen? Okay,
And the side.
good. Actually, it's top and front.
On top.
This fucking shit. This is gonna be side, not just right. It's just gonna be side because we know our sides are gonna be the same. Top, front, side. Right, unless we had a left and a right. Otherwise, we'll just say side because we know that both of these sides are going to be the same, right? Okay, so what 2 views show the width?
Side.
And the width, how wide is it? Front, side. It's not going with your assignment, just so you know. I got the back side here.
Ah,
That's why I gave you the back side. It's not all the same questions though because I kind of condensed it. But I wanted you guys to understand because I just paraphrased when I wrote it. Not exactly the same. So what line letter represents the surface A in the front view? So where's our front view? Okay, now they're asking about surface A. So when we see the leader line with the little dot on it, that shows that it's a surface. Okay, that's the surface. So that's surface A, right? Right here?
That's the
The flat part, the whole surface of the top. That's what they're talking about. Okay, so now they said, see that surface A. Now, in the front view, which line represents surface A? Good, so it's gonna be D, it's gonna be this one, right? Okay, which one represents surface H in the side view? So where's surface H at? Hold on, let's find surface H. So surface H is here. This is at surface H. So in the side view, so here's our side view. Okay, so it's going to be K. This is why I'm bringing this to you guys so that you guys can better understand what they're asking, what they're talking about, and how that you're able to read a blueprint better. It's not going to give you this all the time. It's usually going to give you these. All right, so what letter represents surface C in the front view? Where's our surface C at? Here's surface C, right? Actually, I think I would choose two different ones. O or E, right? Because it's not specific, is it? No, because it doesn't say right side view or left side view. It could be either. If they said left side or right side, that means that the left and right side are different, okay? So we have to remember that. All right. Which line letter in the top view represents surface G in the front? So here's surface G, top view. Look at what we're looking at. What surface? Surface G. So remember, this is the front view, right? So this is where we're looking at. No, H is this. Well, H is this. So it says, which line letter in the top view represents surface G in the front? So top view, right? We're talking about surface G, this surface here, this surface here. Which letter would best represent it?
F.
No, it's not H. H is the bevel.
It ain't F.
It could be, well, like, look, so we could say F, we could say line H, not surface H.
Oh, it's two different ones
There's two
on there.
H's in there.
Yeah.
Right, that's why it's confusing. What do you mean? Yeah, so this is why I'm trying to like show you more, because this is confusing, right? So ultimately, technically, we could say this line, and this line represent this area, right? Because there's not really something very specific. So what do lines L and M represent? Okay, so lines L and M, let's ask you, what is it representing? So, okay, here's line M and line L. Right, so it's the top surface of the groove, right? Top of the groove. Yeah, so this can be really difficult to see because of this. This can look like another plate if we don't have any other information. What does the symbol, the line with the little dot tell me? Look at number 16. What does it tell me? A line with a little dot on it, number 16. Give me an idea, guys. Good, it's a surface. When we see something like that, we know that it's representing a surface. So now when we look and we see this dot here, oh, it's a dot. We know we're talking about a surface. When we see this, oh, it's pointing to a line. Arrow pointing to a line or dot for a surface. All right. All right, do we have any questions? How about where would I put my symbol at? Yeah, where would I put my welding symbol? If I were to weld this together, where might I put a symbol? If I have a top, a front, and a side view. You put it on the side? Okay.
No.
Pixie thing? I like that, the pixie. All right, no, we're not gonna put it on the pixie because let's imagine that the pixie's not there. So I might put it on my side and I might put it on the front. It's really important that we show in the best view possible where to weld it on the drawing itself. So I were to say, really can't see it very well, but V-groove, right? So I'm going to show in the best view possible. If I put it in here, I could maybe even put it here, right? So we want to put it in the view that we're going to be able to understand it best. Now if we put it here, that might be a little confusing, right? So sometimes we have to kind of pick and choose where to put it. You can put it more than once. It's just sometimes though, if we put it more than once, it might not fit on our drawing, or it might make it a little bit more confusing, right? So we want to be as clear as possible when we talk about a drawing. Any questions or confusion about this week's word? There's a humana. No, talk to me. Well, you guys will get more and what we're gonna keep going with it, but I wanna make sure that you guys understand how it works and what you're really looking at. The one from yesterday? All right, so what do we need to understand?
All of it.
All of it? Okay, well you guys are giving me a lot. But we're talking about lines here, right? All right, long, short, long is a center line. Good. Dash, dash, dash. Hidden. Your phantom line's not going to be seen very often unless we're showing movement. The phantom line is like a long, short. So this is a hidden, right? What is it showing me? I want you to look at the picture here. What is it showing? Okay, so we know this is top, right? And this is front, and this is side. Now we notice how they're all relational, right? Okay, so this is relational. So this is a center line, right? What is it telling me? Bingo. It's a hole. It's showing me where the hole's going to be. And this long, short, long shows me the center of the hole because this is relational to this. And this is relational to this. Do you see it better now? It makes sense. Good. All right. What else? What's this one? Okay, so this is the center. These. What is it? Long, short, long. Center. It's showing you a center there. All right. What is this one? Dimension. Good. All right. These are very good. All right. What are the other ones we're running into? Let's see. Oh, what are these ones? Solid line. Good. Yes. Does this make more sense now? Well, maybe you should do your work out loud. Okay. Are there any other questions? All right. So, where would I find tolerance? Tolerance. Right here. So usually it'll be in your title block. Sometimes it'll be in your bill of materials. It'll also give you scale.
Material.
Not your bill of materials will have your materials in it. Okay. It'll show you probably a part number and usually a part name. Oh, material, cold rolled steel. Correct. Yes. Right, this one has quantity, but sometimes the quantity will be on your bill of materials. It'll say, we need this many finished pieces, or it'll say, this piece, this piece, this piece, and this piece are used to make this piece. Depends on how they're using it. If we're using this as a sub-assembly, to a bigger assembly. It can tell you type of electrode, it can also tell you type of welding. It's not going to tell you position, but it's going to tell you SMAW.
Yeah.
Or if it doesn't say that, it'll say use an E7018. Use this rod, use this wire. You should be using this much. This piece is a 5x7 that needs to be put into here. And the 5x7 has a particular part number if you don't have to cut it. Because in some shops, what'll happen is there's one cut guy and he'll do all of the cuts that you need for a particular assembly. Okay, so then you have to go back and you have to measure out, okay, this is this piece, this is this for this part, this is this, this is this, this is this, and you go back and verify all of your cuts. Because what happens if your cut guy deviates? There we go. The parts come out wrong, right? Or too short or too long. But we also have to pay attention to our tolerance, right? So that if I know that my tolerance, it's within tolerance, more than likely I'll be able to put it together. But if it exceeds that, you know my part's gonna be out of square, or I'm gonna have a problem getting things together. All right, any more questions? This one, quantity of parts. I want 25 of these. Make sense? Yes? Now, I kind of had a realization the other day. I don't hear that well. And a lot of people don't really realize it. But I do, because I'll keep saying, what? Huh? I read your guys' lips. So if you guys are yelling and screaming at me and I don't turn around, I just don't hear you. Okay? But, I got some fun stuff too. These ones are 90% welding terms. Some of them I use, some of them I don't, but I thought it would be fun. That way you guys get an idea, and maybe because I do some site and I don't realize it. So I just thought it would be fun that you guys are able to look at things like this and go, oh, okay, cool. And I think it's also fun. There's a lot of people who don't understand. We actually, in Riverside, we have California School for the Deaf. Generally, in very loud environments. Hey, you know what? There's numbers and there's letters. And then I'll show you some of the ones that I usually use in the shop. I wanted to give you guys some stuff that you could actually use. You know, like finger spelling and things like that. Should you run into it. But there's actually a couple of ones that I actually use and I don't really realize it, okay? First one is to grind. Hey, did you grind that?
What?
You're funny.
That's right.
Yeah, did you grind it? Did you grind it?
Oh, yeah.
Okay, to clean? Clean it?
Fresh.
Or to sweep? You just sweep.
Them is the basics.
Yeah, right? Okay. Metal. You need metal?
You did that to him yesterday.
I'm not yelling, I just can't hear you. Oh, weld. Wow. Oh, yes? No. No.
Yes.
Rod. You need a rod. And it's
Yes.
like electricity, and there's all sorts of other ones. Metal to weld, you know, other things to make it flatter or above, over. You know, and there's some, I put in there, oh, do you know someone who can weld? I don't know that one yet. I think it's on the second or third page. I thought it was funny. And that kind of brings me to my other one about noise safety, hearing safety. You guys need to protect your ears. What they found is that the smoke from welding actually affects your hearing. What it is that there's like, they call them little cilia in our ears, okay? When there's a loud sound, the cilia lay down. And then after a while, they kind of come back up. That's why you generally kind of get back your hearing after a loud noise, right? But what they found was these particles actually sit on those little cilia and break them. They don't come back up. Okay? So that means keep your head out of the smoke. And if you don't, wear earplugs. Wear hearing protection. It's very important.
So pods are okay?
I don't mind pods. My problem with pods is that if you can't hear what's going on around you, extremely low volume, because the problem is that what happens if there's something falling down, breaking, fire, whatever it is, you're unable to respond to it because you're in your own world. And a lot of shops do not allow headphones. But not only that, anybody catch one in the ear yet? How's it feel? How does it feel? Right, but it can actually burn you, and it actually can burn your eardrum. It can burst your eardrum. Okay, so it's kind of important. Yeah, any spark that goes in there, a hot piece of whatever, let me tell you, it does not feel nice.
Worse than on the foot?
Worse than the foot. Because you can't get it out, you can't touch it. Yeah, like exactly. So you're just like, oh, you know, and it's very, very painful, and it can affect your hearing. You know, I never thought about, hearing protection when you grind, when you're welding. No, it doesn't make, So I have lost quite a bit of hearing because of it. So I want you guys to make sure that you guys are being safe using earplugs, and we have a ton of them. Please put them to good use. Or, some sort of hearing protection. They do have what's called the ISO tunes, which I think they're about $100. They're wireless headphones, but they're extreme noise canceling, and they're approved by OSHA. Which means you can put your music on, and it only allows it to be a certain volume, and it cancels all of the other external noises to a certain degree, but so that you can still hear it. And it's a lot more that I can provide for you with earplugs. So that is an option. I know I can't, buy them for you guys, but I mean, if you guys want to look into something like that, totally worth it. ISO tunes. So I want you guys just to, be aware. Sometimes we don't realize what can happen. Okay? All right, guys, do we have any other questions for this evening? Any type of smoke from welding?
No matter which line?
Well, okay, so we have to really think about it. What is in that smoke, in that fume?
I'm trying to say that it's bad for your ears, it has to be bad for your respiratory system too.
Right, yeah, it is. Well, there's particulates. Anytime we have a fume, there's a particulate, which means that's little pieces of flux, that's little pieces of metal that's being burnt away. There's cadmium, there's chromium, there's all kinds of stuff in that fume. Yeah, I probably wouldn't want to be breathing it either. Use your brain. If you're running something that's extremely smoky, wear a respirator. It's important. That's your health. You know, you want to continue to weld, make sure you're doing things that you're going to be smart about. Other questions? Concerns? Snotty remarks? We have merchandise. This is the Weld the World merchandise.
World premiere.
I want wayward women to tuck me into bed. I want wayward women like I need a hole in my head. I want wayward women to tie me to the bed. I want wayward women and now my money's spent. Anytime's the right time. Come on, babe, make it feel alright. Anytime's the right time. Come on, babe, make it feel alright. Make it feel alright.